Welcome everyone. This video is a showcase of our machine learning projects, used car and property price prediction. Joined alongside me is Ethan. First, we'll go through the folder structure of our project, then our DVC and ML flow, afterwards how we implemented Bento ML, and finally a web app demo. Ethan will now introduce the folder structure.
Hi, my name is Ethan. Let's go through the group component for MLOps. This is the clone repo from our shared GitHub. App contains the web app, test contain automated tests, and use car predictor will be my part. So firstly, let's take a look at the .dvc folder, which stands for data version control, and it essentially tracks datasets efficiently. Next, we have the Bento ML folder over here, and which hosts the Bento ML service file, which basically conveniently allows for deployment and creation of endpoints, which we will use in the app, in the web app. So next, we have the configs file, folder, which hosts the config.yaml file for Hydra, and it stores parameters for the PyCaret setup function, but can also be used for managing other hyperparameters and settings. So next we have the datasets folder. It just hosts the raw dataset and preprocessed dataset after manual pre-processing on my part. And it also hosts the table of every brand model and their frequency derived from the preprocessed dataset, which I will go through briefly later. And the reason why I get ignore it is because we can use DVC to actually pull the datasets, which I will also show later, since datasets are quite large to push into GitHub. So next we have the experiments folder, which holds the pipeline picker file, and it contains the trained machine learning model along with the pre-processing pipeline. And finally, we have the notebooks folder, which holds the EDA notebook and the model training notebook. Then we have the miscellaneous README and gitignore files, as well as the poetry generated file.
I created the .github folder, which configures the GitHub actions. Taking a look inside, we set the branch to main, start a new job on an Ubuntu server, clone our repo, set up Python, and run our tests. We will then be able to see our run results and a tick checkmark next to our commits. Let's take a look at a short demo of this workflow. I would like to commit this bento/ml change. So first, I'm going to write a commit message, push it to my dev branch, then create a new pull request. This pull request will merge changes from my dev branch to the main branch. Allow me to confirm the merge. Now that the pull request has been successfully merged, let's take a look at the commit. It looks like we are doing some checks. Let's take a look. So it looks like currently the GitHub action has been setting up dependencies. Let's wait a little while longer. And now it's running the property price test and car price test. Looks like it all passed. Property predictor has a similar folder structure. Let's take a look at my Hydra configuration property. I have defined ML flow tracking variables, implemented data loading, data preprocessing, feature engineering, box cox transformations to numerical variables, modeling, deployment, and testing. Notice how almost every part of our notebook can be changed here in a much tidier interface. Let's take a look at the notebooks directory. Notice that the notebook is the only thing tracked when looking at our gig in Node. Let's take a look at pyproject.toml. The pyproject.toml allows for poetry install. Let's take a look at car prices DVC and ML flow by Ethan.
So we have a fresh folder in our IDE, as you can see. So let's git clone our repo. After git cloning it, we can cd to use car predictions. So like so. And now let's do a poetry install. So poetry install. So which basically just installs the dependencies. So meanwhile, let's just have a look at our ML pipeline notebook. But first, let's take a look at the pyproject.2ml file, which is used for environment and dependency management, and the config file, which stores experiment settings for PyCaret. So let's go to the file, and we can see here that we have to pip install poetry, no doubt. And over here in this cell, in this cell just integrates Hydra with PyCaret to dynamically configure the ML pipeline. So instead of manually specifying each parameter in the setup function over here, it fetches the configuration values from the external config.yaml file over here and inside the configs folder. So as you can see, the experiment name is experiment one, so we'll take note of that. And basically this model, I trained it, but I tried to hyperparameter tune it, and the original model is better. But anyways, over here you can see how that I log the metrics, the overview of the model into MLflow. So we can open up localhost 5000 and we can see experiment one, as I said before, it's shown over here. We can click here, car price pipeline, which is the model that I just trained. So we can see the overview, the metrics. We can click here as well. And over here, okay, we have not registered this model, but this model which I trained quite a few hours ago, I registered it, and we can see over here in the models tab. So here we can see that it's over here as a registered model, and its version is one. So if I were to like register another model, it would be two. So that's that for MLflow. So okay, our poetry install should be done. So nice. Let's go set the Google application credentials. So like so. And actually first we can uh copy this and just put inside our use car predictor. Okay, so let's do this. And then we can just DVC pool, which gets the data sets. So actually, I use DVC in conjunction with Google Cloud Storage, which holds the bucket of my data sets, push programmatically with DVC. So essentially, this will just retrieve the latest data sets based on the metadata of DVC. And if I push a new data set and push to GitHub, then the new data sets will be shown up. So we can verify over here our data sets folder. Yeah, so it's about the same. It's actually just the same. Yes, the process Excel file and the CSV file over here.
Let's also replicate the DVC flow on my side as well. I'm creating a new test directory. I'm cloning my repo right now. Okay, nice, it's done. Let's cd inside MLOps. Let's cd inside property predictor. I'm going to do a poetry install to install the dependencies. Okay, then now let's do poetry run dvc pull to pull in the datasets and experiments from my Google Cloud buckets. Nice, the files is now present in the directory. Let's take a look. So here's our CSV file, and these are our experiments. Okay, thanks.
Let's briefly go through the Bento ML part. So the reason why we use Bento ML is because instead of creating a fast API or fast application, you want to have something that's more efficient, something that you don't have to set up a Docker file and push it to Docker Hub and like put it onto Google Cloud Run to just to serve a single server. So we can use Bento ML, which actually automates everything. And over here, you can see all you need to do is actually make one file and you can create the endpoint already. So what we do here is, okay, this is just cause, by default it's disabled, that's why I have to enable it and allow all origins. And I have to pre-process my input because for my individual part, I have to do some pre-processing in my EDF file because PyCaret can't handle some of the pre-processing steps. So over here, I enable batching. So this can allow for multiple predictions at the same time. And yeah, this, okay, also the pre-processing takes this file, the brand model frequency file. Essentially, this just shows the number of times each brand shows up in the dataset. It's called frequency encoding. That's one of the things that I did for my preprocessing. That's why we need that file, and this just predicts the output. So we also have the test folder, the test file over here. So we can see the endpoint, and you can verify it's the same endpoint as this, which I've this is the deployed endpoint. So let's go back and run this. So let's run it, and we expect to see that the outputs are this and this, or within 10,000 of this. So yeah, it is, and this just means the test is passed. So yeah.
Property prices also has their endpoint deployed on Bento ML, and new models are dynamically retrieved from the Bento ML model store. The Bento ML endpoint can also be queried for the latest metadata updates. Now, let's take a look at the web app. So this is the car and property advisor. Let's take a look. We are greeted with a tour. We can click next. These are the presets that we have. It basically breaks our complex farm down into more manageable pieces. So I'm going to do a prediction. We have a predicted value, $1 million, and we have an AI generated report. Now I can save this as suburban. Save this as suburban. Okay, then let's just take a quick look. We have some discounts noted, and with some calculations it gives us a suggestion. Okay, um, yeah, this is all adjustable with the model configuration. Okay, then let's start a new prediction. Let's try a luxury house. Note that everything here can be adjusted as such. Okay, then we can also save this luxury, save, and then we can basically load between the two. Notice 2 million, 1 million, 2 million. Okay, good. So let's move on to batch. I'm gonna download this. Okay, this is an example of a batch. Let's directly upload it in, and we can see we can edit the values, make this 100. Okay, it became 100. Can delete. Okay, let's process them. Okay, once the process is done, we get a summary. We can get the average price across the various houses, the price range, and we can also enable chatting with the property AI and such. So is this a good deal? We can also chat directly with it. Yeah, it's talking about the uh, yeah, can. I guess that's all. Thank you for watching.
So let's go through the web app demo. So this is a Next.js based web app using Bentine UI that allows users to input car details and predict their prices using the Bento ML endpoint. Users can add multiple cars, autofill random examples, and submit a form to get real-time predictions. So yeah, nothing much here. This is just essentially the UI. So let's actually go to localhost 3000, and you can see over here we can input the car details and whatnot. So let's just set example. It just basically it puts in random values for each input. So yeah, we'll just change, and we can remove as well. Okay, so this is just proof of batching. So let's just maybe do 4. Yeah, just 4. Okay, so let's just predict prices here, and we expect to see 4 results. And yeah, so we have 4 results here for each car. So that's all.
In summary, we've completed the entire ML cycle, built an intuitive web application, remotely host our datasets, models, and application, and allow for easy developer onboarding. Thanks for watching.